Well, hey there, gang. We're starting off today not in the shop, but in the cheap showiness of nature. I tried to talk while walking, but the wind was coming off the lake like a knife. The audio was all rumbles and annoyance, so I'm doing a voiceover instead. This was 7:15 a.m., temperature about -3, which would be about 26 Fahrenheit. This is the extreme western corner of Lake Ontario. I have decided not to take on any more repair work this year, and instead follow my creative visions and build something for a change, because I need a little break. You might recall a couple of instances in the last videos where I was talking about roofing noise. That was unexpected and unplanned, and it relates to the fact that a couple of previous generations of owners of my house decided to cover up a major issue with cosmetic work rather than actually fixing the problem, and in the interim it continued to fester. It got worse, and it comes down to me to actually get the job done and pay for the darn thing. And we're not talking shingles here. It's more like a total reframing of the upper part of my house. Very, very expensive. And the roofing contractor upheld every single stereotype we associate with contractors. So I am frazzled. Also, producing videos every week for 6 years leads to the possibility of burnout. Historically, my method of dealing with burnout has involved throwing myself into my work. I'm told that's not optimal. The instrument I propose to build is something I've never actually seen before, at least not in the way that I envisage. I'm thinking about making a cello guitar. In other words, a guitar with some of the properties of a cello. It's going to be a 4-stringed instrument, tuned like a cello, with a cello-like scale length. And I've got some of this European spruce, which has been kicking around for a while. It's very pretty wood, some slight irregularity in the grain. A couple of areas where the grain gets wide and then narrow again. But I have a good feeling about this, so I decided I'm going to use it. I've straightened the matching edges with a hand plane, making a book match, and I'm gluing them together into the soundboard. In keeping with the cello aesthetic, I decided to use some curly maple for the back and sides. Special thank you to renowned woodworking author and local good guy, Vic Tesselin, who volunteered the use of his thickness sander to help size that curly maple. Vic writes for a number of publications. Check out his book, The Minimalist Woodworker. It's a good read. This happens to be Western big leaf maple from the Pacific Northwest. Very pretty wood. My plate jointing jig applies pressure on either side of the board so that they spring up in the center. I apply glue. When I force them down, it's a very tight fit. It's an easy way to clamp them. I'll quickly wipe up some of the glue squeeze out, and I have a clamping stick which is curved. The portion that's in the center of the stick is actually deeper than the ends, so that when I apply clamps on the ends, pressure is applied all the way across the board. One of my habits at the start of any project like this is to take some time and sharpen all of the chisels and plane blades I expect I'll be using during the project. People frequently ask me about sharpening tools, and there are lots of excellent publications on the subject, lots of YouTube videos and other things as well. I use this. This is a Veritas Mark II sharpening system, which is basically a record player with a really gritty record. And I used to work for the company that manufactures these, so, I'm familiar with it. It's rather expensive. There are any number of different systems available out there. They all have pros and cons. You basically get used to whatever you happen to have. I'd like to make a simple mosaic-style rosette, which is pretty Spanish in its origins. Harkens back to my days building classical guitars. This is a much simplified motif, though. To do this, I have to cut a bunch of strips of veneer in various colors, to about 2 millimeters in width. I glue those up together to make lines, and then glue those lines together to make blocks, from which I'll saw inlay pieces. I use tight bond glue for this. I get everything really gluey. Too much is better than too little, because you don't want the lines delaminating when you saw them apart, which can happen, and it's very annoying when it does. To clamp the strips, I simply press them against some aluminum bar stock on this piece of melamine countertop material. And just press them together. That's enough to hold the pieces, and the surface tension of the slightly damp aluminum on the surface holds things in place well. I'll let them sit for a day. I come back with a palette knife and separate the lightly glued pieces. They don't stick permanently to the plastic laminate or the aluminum. These strips are going to end up 1 millimeter in thickness, so I'll do a quick rough cut. I start off with 2 millimeter lines because it's just easier to handle them and glue them. If you tried to do that with like 1 millimeter stock, you would have all kinds of registration issues. This is an old Stanley number 93 bullnose rabbit plane, which I've taken the front off of, and it gets clamped on its side. And there's a little fence here. And I use that to scrape the veneers to thickness. And I check with a micrometer frequently, and I can work to within 1/1000th of an inch, which is great. After the strips are sized to the appropriate thickness, I can glue those together like I did previously, and end up with this little pattern here, a square that has crossing colors, which I can reverse and create a zigzag from. I have a little miter box I made, which allows me to saw the block into little 2 millimeter thick segments, which I'll use to inlay in the soundboard. I drew a circle of the appropriate size so I don't end up cutting way more blocks than I actually need, because this is a time-consuming operation. To prepare the surface of the soundboard, I start off by planing cross grain, which removes a lot of material fairly quickly and prevents tear out that's extremely deep. After that, I'll switch to longitudinal strokes with the grain. To make the black, white, black veneer bordering strips for the rosette, I glued up some material, and here I'm using my heated bending pipe to put a curve into it. Here's my compass cutter, which uses a knife blade, which is adjustable for depth. And I can use this to create really clean lines for the inside and outside of the rosette with no chance of torn grain. The 1/4-inch pin of the compass registers with a bushing that's in the board underneath the spruce here that holds it in position. And I do this in a series of really light cuts. Then I'll come back with a similar jig attached to a small laminate trimmer router and remove the bulk of material between the incised lines. At this stage, the bordering veneer strips are just held in the channel dry. I apply glue to the mosaic and then press it in place between those. When I come back later and top glue everything with some thinned tight bond, those veneer lines will actually expand slightly, as will the little squares as well, locking everything into place. I don't have to be too neat about this because the entire surface of the soundboard is going to get planed and sanded. I use a low-angle block plane. This is all end grain material that I'm planing, by the way, due to the nature of the strips from which it was glued. So a gentle cut and a light cut is necessary. It cleans up pretty easily. I like this pattern because it reminds me of a braided nylon climbing rope or something. Now I can focus on bringing the soundboard to its final dimensions. I have a dial indicator here which lets me map out the topography, see where things are thin or thick. As far as thickness goes, one can work to a specific number, or you could make a device that measures the deflection under a specific load. Some people try and tune the board to a specific audio frequency. For me, it's a combination of things. This is a steel cabinet scraper, which is used to peel off thin little shavings. It allows me to sneak up on things. I always thin the soundboard out to the edges, so it's thickest in the center and about 15% thinner at the edge. So if it's 3 millimeters or 120 thousandths in the center, it'll graduate down to about 2.5 or 100,000 at the edge. The overall thickness tends to be greater the larger the soundboard. A little tiny parlor guitar can be much thinner than a dreadnought. I spend a lot of time picking the board up and just feeling how it feels. The resiliency, you reach a certain point where it wants to spring back at you in a way that feels very friendly. It's very difficult for me to describe this thing because I'm doing it mostly through intuition. But I'll press it against the bench or using my thumbs, and I want to feel a similar kind of resistance across the grain and along the grain. So when I push on the side wings here, it bounces back in a certain way, and it should feel kind of similar in the opposite direction. Now I can come back to my compass cutter and cut out the sound hole. I'm trying something different. A different neck wood. I guess it's an alternative. I went down to the wood store looking to see if they had any maple table leg stock, which I've used before. They didn't have any, but they did have some squares of this beautiful looking birch. Exceptionally tight grain, perfectly quarter sawn. I'm not sure if you'll see that, but it is absolutely vertical. I'm like, I checked out the stats online, brought them up on my phone, because I know that birch is a little lighter in weight than hard maple, and it's softer to an extent. I mean, slightly easier to dent. But I wanted to see how they compare in regards to the modulus of elasticity, or Young's modulus, which describes the deflection of a board under load. And wouldn't you know it, birch seems to be slightly stiffer. I did not expect that. It's about 13.8 gigapascals on average versus maple, which is 12.6. It's lighter, yet stiffer, which happens sometimes. Just for reference, ebony is like 17 on the scale. White pine would be about 9. So with those figures in mind, I looked at the wood and I said to myself, yes, I have the feeling that this will make a good guitar neck. So I've sawn some out here, and there was enough thickness for an integral headstock, not enough for the heel, so I'll have to graft on the heel, but that's fine by me. I do a lot of things with a hand plane, and people ask, again, experience. You just have to practice, and it takes quite a lot of practice, but at a certain point, you become very fast and you become very accurate, and you sort of rely on your senses in a way where you know how much you're taking off without having to stop and measure things very often. Planing my brace stock here. This is some old Sitka spruce. I prefer Sitka for all of my bracing. It's a known quantity to me. I've tried using other woods, but I like it because it behaves the way that I think it's going to behave. I plane every brace to the same dimension to start off with, which lets me gauge how they might differ in terms of flexibility from one to another. They all start off 3/4 of an inch by 5/16. Here I'm splitting out some flat stock for the popsicle brace, which goes along the top of the guitar, and also the sound hole reinforcements. I like to make the back braces from mahogany, or Spanish cedar if I happen to have that, because it smells really nice. But I've got some mahogany that's been kicking around for a while, which I'll use up here. Here's a marking jig I use for marking the radius on my braces, which happens to be a 28-foot radius. Take my brace stock. I've marked a center line on it, which I'll align with the center line on the jig. And then it's just a matter of marking the curve. I plane the curve into the braces with my shooting board here. It's actually kind of amazing how quick and easy this is. If I was going to do batch production, obviously I would make a router jig to do them all with a router and a template bit. But this is more gratifying in a lot of ways. Yeah, it's a big mess, but it's a different kind of mess from the stuff that a router makes. Got an old piece of maple here, which I've planed for the bridge plate. I like them to be about maybe 2.2 millimeters, maybe 90 thousandths. Not super thick, but not super thin. Just a happy medium. And I tend to skew the grain a little bit so that one particular grain line doesn't run through each and every pinhole. Back to the neck. I'm routing the truss rod channel and a couple more for reinforcement sticks of carbon fiber. The carbon fiber gets epoxied into place. These are 6mm square rods, which are incredibly stiff for their size. I mentioned Young's modulus earlier, where ebony might be 17 on the scale. These can be 150. So in my mind, you'd have to present a pretty strong argument for me not to include them, especially in a longer neck like this. This will have a 690mm scale length, which is more than 27 inches. I'll talk more about the philosophy behind the design in the next video. Now I'm into gluing the bracing. Here I'm marking out the positions for the X braces. This is going to be a half-lapped joint. They interlock. One thing I'm not sure it's possible to convey is the pace at which things happen. Makers sometimes talk about being in a flow state, and it's kind of true. Usually to be efficient, you're moving between various components continuously. The glue on something is drying, so you immediately pick up another task and hop right into it, bouncing back and forth. If you sit there staring into space, you lose momentum. So this is very active. The thought process comes first during the morning walk. This is about getting things done, and the bench becomes really messy very quick. I use a go-bar deck to do the clamping, but I don't really love it. If I was doing production work, obviously I'd set up a vacuum clamp or something. Okay, I'm going to carve some braces. This pattern should appear pretty familiar. I'm building something I've never built before, and this is something I know works in guitars of similar dimensions. This is not a small guitar, by the way. It's just under the size of a standard Martin Dreadnought. It's about 15.5 inches across the lower bout. I know that I'm going to want to support some fairly bassy frequencies in a cello, and we get good bass response from standard X bracing, so that's what I'm going with. Carving braces, to my mind, is all about the strategic management of mass as it relates to stiffness. You want things to be just as stiff as necessary and remove as much unnecessary mass as possible while you're doing it. This tends to give you a fairly lively guitar top. There are all kinds of different theories and systems, of course. People who tune various areas to specific tap tones. So one of the primary methods we use is to triangulate the braces. We take them from a rectangle cross-section into a triangular one, and that has the effect of removing quite a bit of mass without reducing stiffness very much. So I think we're going to leave it here this week as I'm in my happy place making little curly Q shavings. You know, if you do this enough, you get to a point where you don't jab the corner of the chisel into the soundboard. There's still a lot of work to do, but I'm happy with the direction so far. We'll see you again soon.